Hello friends, I am Professor ANIL BRAHMIN from Sri Shankaracharya Technical Campus, and in this video we will understand the electric field due to circular line charge density. And for understanding this, we have drawn in this diagram, we have taken a circular loop in the xy plane which is having radius as rho, and our point of interest is on the z axis at the distance z from the origin. This is our point of interest, and we will evaluate the electric field intensity due to this line charge density which is circular at this point. Now the line charge density is rho L coulomb per meter. If you will see this small distance will be rho d phi. dl will be equal to rho d phi. The logic for this derivation or understanding will be, we will divide this circular ring into very small portions as this, and in this small portion we will evaluate the small charge which will be rho L into dl, and due to this small charge we will calculate the intensity at the point of interest by using the well-known Coulomb's law, which is mathematically the intensity at the point of interest will be the charge divided by 4 pi epsilon naught distance square, and one vector is there which is a unit vector indicating the direction, which is very important. We have to understand this also. This vector basically is a unit vector towards point of interest. Suppose we have to evaluate the intensity due to a small charge at this point of interest, we must know this vector, unit vector, which is Ri upon Ri magnitude. If you will see this diagram, this Ri vector towards point of interest will be minus rho arrow plus z az plus z az. This plus this will be negative, this will be positive, and the magnitude of this distance will be rho square plus z square, as it is clear from the diagram also. Thus, for evaluating the dE, which is the electric field intensity due to a small charge on the circular ring, we can write here the rho L into rho d phi, which is the rho L into rho d phi will be the charge, and 4 pi epsilon naught, and now here in place of AI we can write Ri upon Ri magnitude. If we are writing like this, we will have Ri upon, here this Ri magnitude will be cube. This thing we have to note, because AI will be equal to Ri upon Ri magnitude, thus this distance square becomes distance cube. Now we are going ahead by putting the Ri, which is minus rho arrow plus z az, and this distance Ri magnitude is, because it is coming out to be equal to rho square plus z square under root, this becomes rho square plus z square 3 by 2. Power will be 3 by 2. Thus, this is the value of dA. At this point, now we have to again understand which component will be cancelled. Which component of this dE will be cancelled. As it is clear from the diagram, it is having this dE will have two components. If you will see this, it will have one radial component and one component in the z direction, as it is clear from this vector also. It is having one radial and one z component. Now, because this circular ring is having equal and opposite portions, opposite to this will be this, and due to this we will have opposite vectors and which will have again radial component as well as z component. Thus this radial components will be cancelled. Thus if this radial components, because of presence of equal and opposite portions on the circular ring, will be cancelled, this our intensity due to small charge on the circular ring becomes rho L rho d phi to z from here and in the az direction. Other things will be similar. Now for calculating intensity, this d must be integrated from phi equal to 0 to 2 pi. Now here if you will see, rho L is a constant, rho is a constant, z is a constant, 4 pi epsilon naught is a constant, and this rho square z square 3 by 2 is also a constant. Only variable quantity is d phi, which is to be integrated from 0 to 2 pi. Thus the integration will be 2 pi, and if this 2 pi will be there, it will be cancelled with the 2, with the 4 pi, and will have this 2. Thus the result will be rho L rho z divided by 2 epsilon naught rho square plus z square to the power 3 by 2 in the z direction. One thing which we have to say is, if this z becomes 0, which means if this distance becomes 0 here, the electric field intensity will be 0, because the z component will not exist at this point at the origin, and radial components will be cancelled. If z is there, then only the z component will be there and radial components will be cancelled due to equal and opposite portions. This is all about the electric field due to circular line charge density. Thank you.